Hey everybody, welcome back to another chemistry lesson. This lesson is on energy and how it relates to chemistry. Later in the course, we'll get into a more in-depth discussion about energy, but this is a general overview for what you need to know for the beginning of this course. So, energy is a fundamental part of where physical and chemical changes come from. In chemistry, energy is related to the interactions and bonds between atoms that make up matter. And again, we'll get more into that later in the course. But for now, what you need to know is that energy is the capacity to do work. Now, in physics, work is the action of a force through a distance. So if I push a 1 kilogram box 10 meters up a field, that would be an example of work. And by putting energy into or removing energy from a system, a physical or chemical change can be induced. There are several types of energy that we will be discussing in this course. The first one is kinetic energy. Kinetic energy, anytime you see the word kinetic, is the type of energy associated with the motion of an object. A specific type of kinetic energy that is particularly important for this course is thermal energy. Thermal energy is the kinetic energy that comes from the motion of the atoms or molecules that make up a substance and is specifically associated with temperature. So the higher the temperature of a substance, the more thermal energy it has, because the more those particles are moving around. And the other type of energy that we'll be talking about in this course is potential energy, which is stored energy that is associated with the position or the composition of an object. Now, if you look to the left, there is this diagram of a building and a 10 kilogram block on the top of the building. This is a typical physics representation of this. So when that 10 kilogram block is at the top of a building, it has high potential energy because it's got a lot of energy stored, gravitationally speaking, with its position on top of the building. When we push the block off of the building and it falls, there is a lot of motion happening as that block falls. That is kinetic energy. Then when the block hits the ground, we have now lost this distance worth of potential energy. So now if I push the 10 kilogram block, it's not going to fall further. So we have low potential energy. And then you can see here, heat is a way that this energy is transferred when it makes that contact. Again, this is a physics perspective on potential energy. We will talk more about potential energy later in this course as it is talked about in chemistry, but for now, know that it is stored energy related to the position or the composition. Composition is where chemistry really likes to talk about potential energy. So, as we said, energy is stored in an object based on composition or position. The energy stored in the structure of a compound is a type of potential energy that we call chemical energy. Now, potential energy due to the structure of the atoms, the attachment between the atoms' positions relative to each other, and the molecule, or the molecule's relative positions to other molecules in the structure. That all makes up chemical energy. And generally, we talk about this type of energy as being stored in the bonds of a molecule. We will talk a lot more about bonds later in this course. So, just a little bit of recap for you. Energy is the capacity to do work, right? And we have two types of energy, kinetic energy and potential energy. Kinetic energy is due to motion, potential energy is due to stored energy, the energy that could potentially turn into something else, right? Then there is the chemistry-specific version of each. So for kinetic energy, we have thermal energy, which is directly related to temperature. And for potential energy, we have chemical energy, which is associated with the positions of electrons and nuclei relative to other electrons and nuclei. So even though chemistry is the study of matter, energy affects matter. That's why we talk about it. And in physics, we talk about energy being equal to work, which is the force over a distance. So, like I said before, if I push a 1 kilogram block 10 meters down the field, that is work that I am doing. But we need to talk about heat, because this is a really important part of why things do what they do in chemistry. Heat is the flow of energy caused by a difference in temperature, and energy can be exchanged between objects through contact. So when particles bump into each other, they exchange energy. This is how a warm thing coming in contact with a cold thing then results in two things that are kind of in between. This is where that comes from. It's through those collisions. All right, so a really important law that we will use later in this course is that energy is always conserved in a physical or chemical change. And what that means is it is not created or destroyed. All it does is changes types of energy. And we call this the law of conservation of energy. So if you think back to that diagram of the building and the 10 kilogram block falling off of the building, then you'll remember that it was potential energy when it was on the building, and then it was kinetic energy as it was falling. So we didn't create kinetic energy, we just changed the potential energy that did exist into kinetic energy. Systems with high potential energy tend to change their energy in a direction that lowers their potential energy. So if we've got a lot of energy built up, the change is typically going to reduce the amount of energy that's built up, which will then release energy into their surroundings. It's very important that you remember the total amount of energy before is equal to the total amount of energy after. When energy is transferred between objects or converted from one form to another, the total amount of energy present does not change. So here, it might look like this ball has no energy. That's not true. It has mechanical potential energy because it's being pushed down on this spring. So we're not creating new types of energy here. We're not creating new energy. What we're doing is changing mechanical potential energy into kinetic energy, which allows that ball to fly up. So again, if you remember nothing else from this video, total energy before is equal to total energy after. So hopefully you can see that here. This is a demonstration of what happens. Again, we are never creating or destroying energy. What's happening is our system has a certain amount of energy, and the surroundings outside of the system have a certain amount of energy. Whenever an interaction occurs, we are just transferring that energy from one place to another. So here we can see we're halfway full and now we're a quarter full, right? But the surroundings go from being a quarter to a half. So we've not destroyed energy. We've just moved it so that it's now in the surroundings. So again, energy before is equal to energy after any process.